Hi, and welcome to my video solution on binomial expansion. Okay, so we're going to look at using the binomial expansion to estimate roots. Just a reminder, this is the binomial expansion, and we can use this to estimate roots. So let's say the square root of a non-squared number between 2-digit. So let me just ask someone to choose any 2-digit number. 56. Okay, so 56. Okay, fine. Let's say 56. We wanted to estimate the square root of 56. Okay, now here's the trick. Little trick for you. First thing we do is we say, how do I make 0.56? In other words, how do I make as 1 minus question mark? Okay, so I want to estimate the square root of 56 using the binomial expansion. How do I make, or how do I find this question mark? Okay, so if I can estimate this, I know that this is simply the square root of 56 over 100, which is 1/10 of the square root of 56. So if I can find an estimate for this, then I just have to times it by what? 10. Brilliant. So if I can find an estimate, let me just clarify that. So that is equal to root of 56 over 10, or 1/10 of the root of 56. Is that right? So if I can find an estimate for this number, I know that the root I'm looking for, I have to simply multiply this number by 10. Does that make sense? Yeah? So the key to it is how to make the number 0.56. Always the case, okay? 0.56. So how do I get 0.56? Well, 1 minus what is 0.56? If you're stuck, you just do 1 minus 0.56 gives me 0.44. Okay, so it's obvious. Therefore, 1 minus 0.44 is equal to 0.56. So question mark, if you're ever stuck and you can't see it in your head immediately, this, what goes here is 1 minus 0.56. That's the number you choose. A lot of people get stuck in the exam and say, you know, choose a suitable value of x. Your suitable value in this case is 0.44. Okay, so we use the binomial expansion. 1 minus x, and when we root it, what is it? To the power of a half. And here we let x is equal to 0.44. Okay, and when we expand this, we find the first, let's say up to x to the 3. When we let x equal 0.44, when x is equal to 0.44, we're actually finding an approximation, okay? We're finding an approximation to the square root of 56 over 100. Okay, but we want the square root of 56. So what we're finding is 1/10 of the root of 56. And that is equal to something, okay? Or approximately equal to. And we can do that, find that something out. So could you find, let's say up to the x cubed term. I'm going to give you 3 minutes to use the binomial expansion up to x cubed. So when we expand this, it's 1 plus nx. So it's 1 plus n x plus n n minus 1 x squared over 2 factorial shrink it using the technology. And the next one is n minus 1, n minus 2, x cubed over 3 factorial. And we simply simplify that. One minus x over 2 minus 1 over 8x, or x squared over 8, minus x cubed over 16. Is that right? Minus? Yeah, correct. Brilliant. Dot, dot, dot. Should really be putting this as approximate. So, if we wanted to now let x equal to 0.44, I will not be finding the square root of 56. I will be finding the square root of 0.56, which is 56 over 100. Okay, which is, now the root of 100 is 10. So I'll be getting 1/10 of the root of 56. So in other words, 1/10 the root of 56. I'll make it absolutely clear. So in groups, 1/10 the root of 56 when x is 0.44 is approximately equal to 1 minus 0.44 over 2 minus 0.44 over 8, 0.44 squared over 8. Because it continues, that's a good point. Now, if it's an irrational number, it will carry on forever, isn't it? We know that it's a non-ending decimal, and the binomial expansion carries on, okay? And we just approximating the value. Good question, good interruption halfway through. And the final one is, I should just actually write a bit smaller, but there you go. Okay, and the last one, if we wanted it up to the x cubed term, is 0.44 cubed over 16. Now I could actually, once you realize that, you could actually say, okay, just to save you the time, you can say, okay, well, I know that I'm getting 1/10 of root 56. I could say root 56 is actually approximately what? 10 times that, okay? Brilliant. Have you tried that on your calculator? Okay, let's just try that on our calculator. 10 bracket 1 minus 0.44 over 2 minus 0.44 squared 0.44 squared over 8 minus 0.44 cubed over 16. Close bracket. Okay. 7.50476. Yeah. But now So that is using the binomial expansion. But now, okay, if I press the square root of 56, that is an approximation, yeah? So it's the 1 decimal place is accurate. Can you see that? And obviously the more terms you use, the more accurate your approximation is. So therefore, actually, that's another good point. I suppose if you've got time in the exam, you can actually stick in those numbers and check that it is an actual approximation. Now, the big mistake is not to times through by the 10. This is it, because when I substitute 0.44, I'm not actually finding the estimate for the square root of 56. I'm finding the estimate for the square root of 0.56. Okay? And I have to understand that as a fraction, 0.56 is 56 over 100. And from there, I can adjust it. Are we all clear on that?